Hello students, welcome to series of lectures on digital speech processing. So in this video you'll be able to learn the topic on statistical model of ASR. In the previous video we have already seen some of the examples which are related to the hidden Markov model process. Okay, now we need to develop a model that is statistical in nature. Okay, I clearly mentioned in the introduction part of this unit that we need to design acoustic model and then language model. So these two models which are referring to the statistical model only. Okay, so before we start further discussion, now let us look into our concentration towards understanding of statistical model of automatic speech recognition. So let's get started. Now on completion of this lecture you'll be able to understand the statistical model for speech recognition. So this is a weather example we have already seen for the hidden Markov model. Okay, so here the states are hidden. Okay, when you compare the example of the previous topic, so there the observation states are visible to us, but in this example the observation states are not visible. Okay, so with the help of one evidence only we are going to be calculating the probability of expecting something. In this example how we are predicting the weather. Okay. Alright, now let us look into statistical model of ASR. Okay, so let me take the pen. Take this. Okay. Alright, so first what we are doing is that this is a word source. That means imagine a situation, you are a speaker, you are addressing something to the large gathering. Okay, so you are going to be addressing large gathering and you have already got what you need to speak. Okay, so this is a word source, and from the word source you will be having set of sentences, or the paragraph is there, and the same paragraph you need to produce. Okay, so this is a word sequence. The words are coming from the word source and the speaker has to produce the same thing, and you'll be getting the, if you want to represent that in the pictorial representation, it could be the speech waveform or the acoustic. Okay, now this is the channel, the acoustic processor. So the acoustic processor will do the process of the parameters, evaluation and everything, playing windows, framing, taking the utterances, and we are going to be taking short time energy, the parameters you are going to be evaluating from the speech signal that you have got, and every analysis that we will be doing here in this process. Now, so this is the A. A is nothing but acoustic signal observed by the recognizer. Okay, where W is the string of words which is coming from the word source. A is the acoustic signal observed by the recognizer. Okay, now if that give to the linguistic decoder, this is nothing but collection of these two blocks is nothing but the ASR system. Okay, now you'll be getting W cap. W cap is the expected written language. Okay, so in this example, so the set of sentences that can be generated should be depends upon the speaker utterances, the voice modulation and everything that we need to consider. But here W cap is nothing but the estimation of the word, because as ASR is nothing but converting from the utterances, the spoken utterances into the text. Okay, so here what we are doing is that the probability, we need to calculate the probability of word for a given acoustic. Yes or no? We need to maximize this. Yes or no? So probability of W, nothing but words for a given acoustic. For a given acoustic which is spoken by the speaker from these utterances, which we are converting that into the text. So that means if you want to represent into the probability, this is the way how we are seeing. So probability of word for a given acoustic. So this we can also write like this, or maximum of probability of, using Bayes theorem, probability of A by W, that is acoustic for a given W, into probability of W by probability of A is also there. But in this example, if you record one sentence, the probability of acoustic is constant for all the time. So therefore we can ignore this denominator. Okay, we can ignore this, or we can equate this to 1. So therefore you will be getting this equation using Bayes theorem. Okay, so in this probability of A by W is nothing but the acoustic model, and this probability of W is nothing but language model. So these two models we need to learn in this unit. These are very important for us. The same thing I have represented in this slide. In speech recognition, the basic idea is to find the most likely string of words given some acoustic input. Okay, so where W is a string of words and L is a language that you are interested in. Alright, so this also we clearly seen. So one thing you need to understand, so how we are comparing the weather example that we have already taken into consideration in the last video with the speech model. The speech system, when you take, the acoustics are our observation, similar to the umbrella observation that we have already taken, and the words which are similar to the weather states. Okay, so this way you need to understand. This also we clearly mentioned in the previous class. Alright, so this is a statistical model this before we have done. So this is another scenario, how the speaker has to speak the words which are already there. That means it is prompted, something that is already available, the same thing you are giving. Okay, so that the cap is the estimated output string of words in the written language. W must be also the written language. So in the scheme shows the situation where the speaker is given a text and reads out aloud. That is what I am doing. So what does the speaker do? The speaker's functions are understanding the input message W in the written language and generating the message S in the spoken language. Okay, so written language and then spoken language. First, the speaker has to understand what is already there in the file. Okay, so that we are going to be reading loud, and we are having the acoustic waveform. We are processing that with the help of the time domain methods, and then we are getting the W cap as the estimated word string. So this is what the speaker will do. So what are the limitations? So these are three important limitations we'll be having in the statistical approach. First one is that it does not make the distinction between the spoken language and the written language. Yes, sir? Because the written language is already there, we are taking that by a speaker to convert that into the acoustic. Okay, this machine does not compare the distinct between the spoken and written language. That is the first limit. The second limitation, the noisy communication channel model does not approximate the situation involving ambiguity. For instance, let me take one example. If the speaker is telling ice cream, so this is ice cream. Okay, he's telling the sentence ice cream, and the ASR will understand either this way or this way. See what I am writing here. Both the sentences sounds the same. Yes or no? This is the first one. So this is the first one. This is the second one. The speaker is telling ice cream, whether it is ice cream or ice cream. Okay. So it is very ambiguity for the machine to understand what the speaker exactly wants to expect in the word. Okay. Text message. Okay. So this is another limitation. And third one, it is impossible to use a higher order statistical beyond word trigrams. So this word trigrams, word bigram, unigram, that will be related to language model, that is probability of W, that we can see. These are the three important limitations we have for statistical approach. Thank you, student. Thank you for watching this video.